Good morning everyone. My name is Sakshi Otkar and today we are going to see the applications of random theory and mathematical expectation. The first application is insurance, estimating expected payouts for policies. Insurance companies use mathematical expectation to calculate premium accounts and amounts and manage risk. Second one is gambling and games, calculating fair games or predicting profit or losses. A gambling, the expected value helps in determining whether a game is fair or profitable. Third one is weather forecasting, probability of rain and storms, etc. Meteorologists use probabilistic models to predict events like rain, storms. Fourth one is medical diagnosis. Bias in probability in test accuracy. Bias in probability and expectation are used in interpreting test result. The technical applications are machine learning. Machine learning is used to find loss functions often involve expected values. In electrical and communication systems, random processes model noise in signals. Mathematical expectation helps calculate the mean signal variance and power of noise. Second one is machine learning. Algorithms use expected value of the loss function over data to train models. Thank you. Good morning everyone. My name is Sakshi Hotkar and today I am going to solve a problem of probability theory and random process. So this is the problem. A random variable x has the following distribution. Here a distribution is given. For x is equal to 1, the probability of x is 2k. For x is equal to 2, the probability of x is 4k. For x is equal to 3, the probability of x is 6k. For x is equal to 4, the probability of x is 8k. For x is equal to 5, the probability of x is 10k. For x is equal to 6, the probability of x is 12k. So we have to determine k, p, x less than 4, probability of x greater than 2 and less than 5, e of x and variance of x. So let's first find out a. First one, the value of k. The value of k is the sum of probabilities that must come 1. So its formula is summation of I is equal to 1 to 6 pi is equal to 1. So we have to add the probabilities of all the x present over here. So 2k plus 4k plus 6k plus 8k plus 10k plus 12k is equal to 1. So the total addition of all the probabilities of x is 42k. 42k is equal to 1. So k is equal to 1 by 42. So b is probability of x less than 4. So to find out probability of x less than 4, we have to add the probabilities of x is equal to 0 plus p of x is equal to 1 plus p of x is equal to 2 plus p of x is equal to 3 up to 3. Then we'll write the values of probabilities of x. 0 probability of x of 1 is equal to 12k, probability of x of 2 is equal to 4k plus probability of x of 3 is equal to 6k. So the total addition of all this is 12k. So divide the 12 by 42 because the value of k is, since the value of k is 42. So the answer is 2 by 7. Now let's find the C, that is probability of x greater than 2 and less than 5. Now we have to add probability of x is equal to 2 plus probability of x is equal to 3 plus probability of x is equal to 4. The value of p is equal to x is equal to 2 is 4k. The probability of x is equal to 3 is 6k and the probability of x is equal to 4 is 8k. By adding this we get the value 18k. Now let's divide this by 18 by 42. The answer is 3 by 7. Now let's remove e of x. The formula for e of x is equal to summation I is equal to 1 up to 6 pi xi. 1 of 2k plus 2 of 4k plus 3 of 6k plus 4 of 8k plus 5 of 10k plus 6 of 12k. By substituting the values of all this, we get the value 182k. Now divide this 182 by the value of k, that is 42. We get the answer 4.33. So our e of x is 4.33. Now let's find variance of x. The formula for variance of x is equal to e of x square minus e of bracket of square. So let's find out first e of x square, that is equal to xi square pi. Now substitute the value of xi and square it and also multiply it by the value of pi. So I am substituting the values. Now the values of 2k1 square is 2k. The value of 4k2 square